This is Zackary Silber reporting live from StatWatch. Tonight, we are going to be exposing how headlines hijack statistical tests to make fake claims sound scientific. P-values, ANOVAs, and averages are all powerful tools, but when they're misused or misunderstood, they create a dangerous illusion of uncertainty, or rather, certainty. Let's peel back the curtain on the headlines that have fooled millions to this very day. We'll be looking at the p-value scam, and this is in particular with the headline Smart Candy Boost IQ, proven by science. So in a sample of just 10 people, researchers found that Smart Candy used scored average of an IQ of 101, while the control group averaged 100. That's a 1-point difference. The p-value, 0.049. So cue the headlines, Smart Candy works. But hold on, a 1-point change in IQ, that's like adding a grain of sugar to the ocean and calling it sweeter. Extremely misleading on a minimal scale. This is a classic case of overhyping statistical significance. The p-value being below 0.05 only means the observed result is unlikely if the null hypothesis was true. It does not mean that the result is important or useful. A 1-point IQ increase is almost certainly within measurement error or random variation. And with a tiny sample of 10 people per group, it's highly likely this result would not replicate whatsoever. Without practical significance or a meaningful effect size, this statistically significant result is just a statistical noise with good PR meant to mislead the millions of people watching it. From this, we'll be looking at p-hacking in the wild, and the headline for this one was, "Wearing red boosts confidence on Tuesdays." So, here's what they don't tell you. The researchers tested 30 things on this one. Shirt color, sock length, moon phase, whatever you're thinking, they probably tested it. And only gave one p-value under 0.05. That's like flipping a coin 30 times and calling yourself a psychic when it lands heads once. So, p-hacking is when the researchers run lots of statistical tests and cherry-pick ones in particular that gives a significant result. So that significant result is basically when the more tests you run, the more likely you are to find a false positive. If you test enough nonsense variables, one will eventually show a fluke. This practice undermines scientific integrity, and without corrections like Bonferroni or transparency in methods, readers are left thinking random noise is solid evidence. It's not just bad science, it's statistical illusionism, and it's downright lying to the people of this nation. I'll be including the graph right here so you guys can follow along with me. But after this, we look at correlation chaos, which is ice cream sales that cause shark attacks. So let's look at the numbers. As ice cream sales go up, so do shark attacks. So clearly, we need a national cone ban, right? Or maybe it's just summer. Correlation does not simply imply causation, and yet it's one of the most abused statistical concepts in media. Two variables rising or falling together does not mean one causes the other. In this case, the third variable is without a doubt temperature. Hot weather causes both more people to swim and also more people to buy ice cream. The observed correlation is real, but the implied relationship is wrong. Without careful analysis, headlines like this can drive fear or false conclusions, especially in public health or policy. And again, this graph will be right here so you guys can follow right along with me. So, we be going into ANOVA abuse now. And the headline for this one was, "Vegan diet is the best diet," and science confirms this. 3 diets, 3 groups. They ran an ANOVA and found a difference. But which diet was actually better? There's no post hoc test, no follow-up, just big claims and small samples, all to mislead people like you and me. ANOVA, or analysis of variance, tests whether there's a statistically significant difference somewhere between 3 or more groups, but it doesn't say where the difference is. Without post hoc tests like Tukey's HSD, we don't know if one diet was better than the other, or if the differences were between 2 other groups entirely. Also, if the sample sizes are smaller, the assumptions of the ANOVA are not met, the results may not be reliable. Claiming proof from an ANOVA without showing effect sizes or group comparisons is a classic example of overstating findings just to mislead people again like us. From this, we'll be going into misleading averages, and it's the headline that Brooktown residents make $100,000 on average, which sounds impressive, right? I wish I was over there myself. $100,000 for a reporter like me would go a far way. But that's until you find out that 9 out of 10 people are making $30,000, and one billionaire skews the entire average. That's the mean. But the median income, just $32,000. Big difference. The reason why this is misleading is from the skewed distributions, like income, home prices, or wealth. The mean can be pulled dramatically by extreme values in either direction. That makes it a poor reflection of what's typical. The median gives us the midpoint, half above, half below. In this example, the mean income paints a rosy picture that hides economic inequality. The trick is common in policy and real estate reporting, where inflated means can falsely suggest prosperity, which is meant to just trick us yet again. Summing up, I want to make sure you guys walk away with knowing that statistics are meant to clarify, not confuse. But when misused, they do the opposite. P-values are not proof. Correlation is not causation, and the mean can be misled easily. Before you believe a flashy headline, ask, was the sample size reasonable? Was the effect size meaningful? Were multiple tests run? What kind of average did they use? If the answers are murky, probably the stats are most likely as well, which is the biggest red flag anyone can ever notice within these kinds of tests. So, I'm Zackary Silber. I'm going to be reporting live from Stats Watch, and I'm urging you all, everyone that's watching me tonight, to be curious, skeptical, and statistically literate. I'm Zackary Silber, and I'm wishing you guys a good night. Take care.